Here we go. We're going to talk about Ferris wheels and sine applications, or making a trig curve from data on a Ferris wheel as we travel around in a circle. So George Ferris built the first Ferris wheel in 1893 for the World's Columbian Exhibition in Chicago. It had 30 passenger cars, was 260 feet tall, and rotated once every 9 minutes. When all the cars were loaded, the ride cost 50 cents. Assume the Ferris wheel is loaded from the ground level. All right, we're going to start by sketching a detailed picture of your height as you ride on the Ferris wheel. Assume time starts while you are at the 3 o'clock position and the Ferris wheel travels counterclockwise. So let's go ahead. We're going to sketch a picture. First thing we know is we get loaded from ground level. So let's go ahead and draw the ground level. And of course, we have a Ferris wheel, which we know is circular, okay? And with that being said, here you are, you're down here at the bottom, getting ready to get loaded onto that Ferris wheel. Now, we know that with the Ferris wheel, we've got the center, okay? And we know a couple of other things. We know, for example, that it was 264 feet tall. So let's go ahead and say that at the top, we have a height of 264 feet. And at the bottom, we know we are at, the height is at 0 feet. Okay, and there's some other places that we actually know too that are really obvious, but a lot of people don't think about it. It's right here in the middle. We know that the height at the 3 o'clock position, we know right there, this is our 3 o'clock. Okay, we know that the height is half of 264. So we can find the average, 0 plus 264 all over 2, which is going to be 132. So we know at the middle, you're at 132 feet at the 3 o'clock position. Now, something else you know is over here on the opposite side, you're back at 132 feet. Okay, you're back at 132 feet. Now, with that being said, it also gives us a couple other things that we can label on our Ferris wheel. Okay, as we go around this, it says that it takes 9 minutes to go around once, and then it also goes counterclockwise, is what we know. Okay, so that says that right here, counterclockwise. So when we go counterclockwise, we have to remember that counterclockwise is going against the clock. It is going in this direction. And we know that time equals to 0 at the 3 o'clock position, because that's when time starts. Now, we have to know, well, okay, time equals 0 at the 3 o'clock position, and it takes 9 minutes to go around. Well, what we just discovered was, well, we could take this circle and we could break it into quarters. So let's take 9 and divide it into 4 equal pieces. Well, if you don't know what 9 divided by 4 is, and we just come over here and we say 9 divided by 4, we throw it in there, and it gives us 2.25. Okay, and so I know that when I get to this point, t equals to 2.25. And then when we get to the next point, when we travel down to here, t equals to 4.5, and that's just because it's 2.25 plus 2.25. And then we go another 2.25, which is going to be 6.75. Okay, and then we add another 2.25, and that is going to bring us back to 9. Okay, well, we've got a nice little graph there. We know our picture. Okay, so let's go ahead and go to the next one. It says, assume this Ferris wheel's motion is counterclockwise. If the time starts when you're at the 3 o'clock position, at what heights will you be for the given time? So we know at time equals 0, we're at 132. And at time at 2.25, we're at 264. And then at time 4.5, we're at 132. 6.75, we're back down at a height of 0. And at time at 9, we're back at 132. And what we have is there is our first rotation of the circle. So that actually kind of gives us what our period is. Our period would be 9 minutes. Okay, and we can continue going because that's what it wants us to do. If we go another 2.25, it brings us back to the top, 264. If it brings us to 13.5, that's going to be back down here, that's going to bring us back to 132, and 15.75 brings us down to height of 0. And then back at 18 for our second rotation ending, we are back at 132. So the question is, now sketch a graph of what your height should look like, or where your height should be as you travel this Ferris wheel during the two full rotations. So, okay, so let's do that. I'm going to draw an X and a Y axis. Okay. And we have our x-axis. Our x-axis is going to represent the time, and the y is going to be our height. Okay, and we can just really just nice and easily label all these points. So we know we've got 0, we've got 2.25, we've got 4.5, we've got 6.75, we've got 9. Okay, and then that would be our first rotation, and then of course we've got our second rotation that we have to get to, which will be 11.25. We got 13.5. We got 15.75, and we've got 18. And once we do that, I'm going to go ahead and mark the most important points. You'll notice that 132, 264, and 0 keep showing up. So we've got 0. I'm going to put 132. And then I'm going to put 264. There's our height. And now I am literally just going to go through here at 0. Let's go ahead and use a fun color. Let's go with that. Okay, at 0, we are at 132. At 2.25, we are at 264. And we just keep running the data points based off of our table. 6.75 we're at 0, and 9 we are at. Back in the middle. Okay, and then we just keep following it out until we have that full graph organized. And one thing we could do is, as we looked at previous circle information, our graph is curved. It's not straight. So we've got these nice curves that are coming along just like this. Okay. All right. Now, once we have that information, I'm going to ask you, okay, well, we've sketched the Ferris wheel. Okay, we've sketched a picture of the Ferris wheel. We've labeled our times based off of the quarters. We've set up a table, and now we've made a full graph. What I want to do is identify the midline, amplitude, period, and B value, and is this sine or cosine? Okay, so let's identify the midline. So the first thing when we identify the midline, and y'all should know this by now, is we go right through the middle. Well, guess what? Our middle or midline was the 3 o'clock position on the Ferris line. So our midline is going to be 132. Well, what is our amplitude? Well, our amplitude, if you remember, is the distance from the midline to the crest, the peak or the maximum, or the midline to the minimum. Okay, and what we know is, well, I could take 264 and I could subtract 132, and that gives me 132. So the amplitude is got to be 132. Okay, and then we're going to go ahead and find the period. We know the period is going to be 9 minutes. And that is for 1 revolution, okay? And that's the important thing to remember, is that the period is only how long it takes to do 1 full revolution. There is 1 full revolution right there, and we can count it in quarters as a Ferris wheel, to the top, to the middle, to the bottom, back to the middle. And that gives us a revolution of 9 minutes. So that is 1 period equals to 9 minutes, okay? Now what we have to do is we have to look for the B value. Now, the B value is a little bit different. Remember that the B value is the number of periods in 2 pi. Well, how do we figure that out? Well, it's nice and easy. B just equals the number of periods into 2 pi. So we take 2 pi and we divide it by the period, which in this case, the B value would be simple, 2 pi over 9. Okay. Now we have our table, we have our sketch, we have our table, we have a graph that we've sketched, and we've got a all of our information, midline, amplitude, period, and we know that this is going to be in fact sine because it starts on the y-axis at the midline. Okay, so that tells us it is sine. Now let's go ahead and write an equation, and if we remember from our desmos activity that the sine equation is simple, a sine bx plus k. This is our midline. This is our amplitude. This is the b value, of course, it says it right there. So I'm just going to write it y equals 2. It's a positive sign because it's going up. Our amplitude of 132. Sine, our b value is 2 pi divided by 9 times x. And our midline is 132. So what we're going to do now is we're going to go ahead and go over to Desmos and let's type that in. So we have 132 sine 2 pi divided by 9 x, and then we're going to add 132. I'm going to go ahead and make sure we are in radians because we are talking about radians in this case, and we wanted to see the revolution based off of our class kick between 0 and 18. So I'm going to put 0. I'm going to put 18 as our x because that is our time. And then I'm going to show my y-axis, which we know is 0, all the way up to about 264. And we can get a nice little graph and we can see how our graph works out. Sometimes what I like to do is to make sure that I'm doing this right, I'll put the ending point that I know. So x equals to 18 should be the end of our graph. And you can actually see that we're back at the 3 o'clock position at x equals 18. That just helps us out. Now, last question on this class kick says, what is the rider's height after 7 minutes? Okay, well, 7 minutes, that's our x. X is our time. So since x is equal to time, I'm going to say that I want to know the answer. What is the y value when x equals to 7? So let's go back to Desmos and let's plug it in. Let's find x equals to 7. And we can find out the height at 7 minutes. At 7 minutes, it looks like, oops, wrong one, that we are at about 2 feet above ground level. So 2 feet above ground level. Remember, we can also give our function a name. So let's go ahead and maybe call it f of x equals, and then I can also put f of 7 and make the calculation. That way it comes out to be exactly the same. All right, that is Ferris wheel and sine curve. I hope that helps you out.